Through project-based learning, your students acquire science knowledge through implementing a specific science-related task. Through project-based learning, your students might participate in urban planning, design a model or a prototype of a system to retain water runoff from streets, restore habitat for bird species, launch a program such as school food waste composting program, create educational videos and podcasts, or volunteer to educate younger students and community members about plant-rich diet. Let's look at this particular example of project-based learning. In the US, there's a nationwide competition for middle school students called Future City. The goal is to design and build small-scale models of environmentally friendly cities of the future. Students go through several steps. First, they choose which sustainability issue their model will address, such as sustainable transportation, green energy, or carbon emissions. The students design innovative urban systems, including buildings, roads, and green space that satisfy environmental sustainability requirements. As students develop a model of their sustainable city, they also consult with scientists, engineers, and other experts. Finally, they create a city model or prototype that integrates ideas from STEM and other disciplines, including social sciences and aesthetic design. As students go through this project-based learning process, they also practice teamwork and collaboration, integrate E-STEM disciplines, and use disciplines outside STEM. Let's explore these three aspects of project-based learning, starting with teamwork. Research shows that project-based learning can help students develop social and collaborative skills. Why? Because project-based learning is often done in small teams of 2 to 5 students. Whereas each student may contribute to all tasks, he or she is primarily responsible for one task. For example, students working on a future city project in which they build a model or a sustainable city might split up the tasks. One student takes primary responsibility for conducting research about green infrastructure, another explores access to green space in poor and rich communities, a third develops energy-saving ideas for future cities, and a fourth builds a physical model. But maybe all students collaborate to develop a presentation for their model. Through practicing teamwork, students improve their verbal and nonverbal communication skills, learn to support other team members, and take responsibility for completing their primary tasks. Other aspects of project-based learning is that students have to integrate ideas from different disciplines. This is a powerful learning feature because in schools, various disciplines are usually taught in isolation from each other, whereas in the real world, teams of people integrate their knowledge from multiple disciplines to address actual problems. In our example of building a future city model, students integrate such diverse subjects as engineering, ecology, geometry, design, and technology. In the process, they develop interdisciplinary thinking and create novel ideas for their projects. Finally, project-based learning often integrates knowledge from outside STEM disciplines. For example, many STEM-related projects bring in art, as captured in the acronym STEAM: Science, Technology, Engineering, Art, and Math. In developing their projects, students may also bring in psychology and social sciences. For example, they might want to understand people's attitudes towards urban agriculture and use that information in their sustainable city design. In sum, if students are engaged in project-based learning, such as designing an aesthetically pleasing and sustainable city that enables equitable access to green space, clean water, and clean air, they will integrate multiple disciplines ranging from ecology to art and design to psychology and economics. In doing so, students will come up with novel sustainable models and plans while experiencing the creative tension of working as a team.